The halogens are the group 17 of the periodic table. It's a series of nonmetal elements. The halogens include fluorine, chlorine, bromine, iodine, and astatine. When halogens react with metals, they produce a wide range of salts. Therefore, the English word of halogen is from Greek. Halos, meaning salt, and genon, meaning form. Halogens are highly reactive, and they can be harmful or lethal to biological organisms in sufficient quantities. This reactivity is due to high electron negativity and high effective nuclear charge. Halogens can gain an electron by reacting with atoms of other elements. Halogen elements are elemental diatomic molecules. The changes in their physical properties are very regular. With the increase of molecular weight, the halogen dispersion forces between the molecules gradually strengthen, and so the color of the elements down the group gets darker. Their melting point, boiling point, density, atomic volume is also increasing in turn. The elements in halogen group all have oxidative ability, with that of fluorine being the strongest. The halogens become darker as you go down the group. Fluorine is very pale green gas. Chlorine is greenish yellow gas. Bromine is a reddish brown liquid. Iodine is a gray solid that sublimes to a purple vapor. Astatine is a black solid and radioactive. Fluorine atoms have the lowest melting and boiling point. However, when you go down the group, the melting and the boiling point of the atoms increases. Move down the group, the reactivity of the halogens decreases. A more reactive halogen will always displace a less reactive halogen in a compound. We will demonstrate these displacement reactions using aqueous solutions of potassium chloride, potassium bromide, and potassium iodide. These are all halogen-containing compounds. In the periodic table, the atomic number, which is the number of protons in an atom, defines what element it is, and also determines the chemical behavior of the element. For example, hydrogen have 1 proton, helium have 2, and lithium have 3. The number of protons in an atom is referred to as the atomic number of the element, and is the line from left to right of the table, also called a period. This explains why in group 7, fluorine atom have 9 protons as there are 8 different elements before it. As we move down the elements in group 7, the number of orbitals increases because they are in different periods. At this time, there is a maximum of 7 electrons orbitals, so being in the second period, fluorine from group 7 has 2 orbitals, chlorine has 3, bromine has 4, and so on. The fluorine's electron configuration is 2, 7, chlorine's 2, 8, 7, bromide's is 2, 8, 18, 7, iodine's is 2, 8, 18, 18, 7. The elements in each group have the same number of electrons in the outer orbital. Those outer electrons are also called valence electrons. They are the electrons involved in chemical bonds with other elements. Hence, the elements in group 7 all have 7 valence electrons and consequently behave in a similar fashion chemically. Due to relatively weak intermolecular forces, chlorine and fluorine form part of the group known as elemental gases. The boiling points of halogen increase down the group due to the increasing strength of van der Waals forces as the size and relative atomic mass of the atoms increase. This change manifests itself in a change in the phase of the elements from gas to liquid to solid. The halogens are the only periodic table group containing elements in all 3 familiar states of matter and standard temperature and pressure. With halogens, the atomic radius increases as you go down the group. This is because the radius of an atom is governed by the number of layers of electrons around the nucleus, the pull that the outer electrons feel from the nucleus. The only factor which is going to affect the size of the atom is therefore the number of layers of inner electrons which have to be fitted in around the atom. Obviously, the more layers of electrons you have, the more space they will take up as electrons repel each other. That means that the atoms are bounded to get bigger as you go down the group. Also, as you go down the periodic table, the reactivity of the atom will decrease because of the increasing size of the atoms. Comparing halogens to noble gases. Halogens are highly reactive unlike the noble gases. The alternate rule states that atoms tend to prefer to have 8 electrons in their valence shell, so will tend to combine in such a way that each atom can have 8 electrons in its valence shell, similar to the electronic configuration of a noble gas. In simple terms, molecules are more stable when the outer shells of their constituent atoms are empty, full, or have 8 electrons in the outer shell. As halogens, they have 7 balanced electrons, and so they only need one more to complete their orbit, and they will do all they can to get this electron. Because they will be willing to do anything to get this electron, they have a high level of electronactivity. This describes the strength or tendency of these elements to take electrons from other atoms. Fluorine has the highest electronactivity. Reaction involving elements from the halogen family usually results in the formation of salts in compounds. As you move down the group, atomic radius increases. This is because the number of energy levels increases as you move down the group as the number of electrons increases. Each subsequent energy level is further from the nucleus than the last. Therefore, the atomic radius increases as a group and energy levels increase. However, as you go across a period, electrons are added to the same energy level. At the same time, protons are being added to the nucleus. The concentration of more protons in the nucleus creates a higher effective nuclear charge. In other words, there is a stronger force of attraction pulling the electrons closer to the nucleus, resulting in a smaller atomic radius.